Section 2, Studying Earthquakes. The study of earthquakes and seismic waves is called seismology. Many scientists study earthquakes because earthquakes are called the best tool. Earth scientists have for investigating Earth's internal structure and dynamics. These scientists have developed special sensing equipment to record, locate, and measure earthquakes. Recording earthquakes. Vibrations in the ground can be detected and recorded by using an instrument called a seismograph, such as the one shown in Figure 1. A modern three-component seismograph consists of three sensing devices. One device records vertical motion of the ground. The other two devices record horizontal motion, one for east and west and the other for north and south motion. Seismographs record motion by tracing wave-shaped lines on paper or translating the motion into electrical signals. The electrical signal can be recorded on magnetic tape or it can be loaded directly onto the computer that analyzes seismic waves. The tracing of the earthquake motion that is recorded by a seismograph is called a seismogram. Because they are the fastest moving seismic waves, P waves are the first waves to be recorded by a seismograph. S waves travel much slower than P waves. Therefore, S waves are the second waves to be recorded by a seismograph. Surface waves, or Rayleigh waves and Love waves, are the slowest moving waves. Thus, Rayleigh and Love waves are the last waves to be recorded by the seismograph. Figure 1. Seismograph stations has banks of seismographs to record earthquakes. Each type of seismograph wave is a unique signature on a seismogram. Locating earthquakes. To determine the distance to an epicenter, scientists analyze the arrival times of P waves and S waves. The longer the lag time between the arrival of the P waves and the S waves is, the farther away the earthquake occurred. To determine how far the earthquake is from a given seismograph station, scientists consult a log time graph. This graph translates the difference in arrival times of P waves and S waves into distances from the epicenter to each station. The start time of the earthquake can also be determined by using this graph. To locate the epicenter of the earthquake, scientists use computers to perform complex triangulations based on information from several seismograph stations. Before computers were widely available, scientists performed this calculation in a simpler and more impressive way. On a map, they drew circles around at least three seismograph stations that recorded vibrations from the earthquake. The radius of each circle was equal to the distance from the station to the earthquake's epicenter. The point at which all circles intersected indicated the location of the epicenter of the earthquake. Figure 2. In 1995 in Kobe, Japan, the 1995 earthquake in Kobe, Japan had the moment magnitude of 6.9 and lasted 20 seconds and killed 5,470 people. Earthquake measurements. Scientists who study earthquakes are interested in the amount of energy released by an earthquake. Scientists also study the amount of damage done by the earthquake. These properties are studied by measuring magnitude and intensity. Magnitude, the measure of the strength of an earthquake, is called magnitude. Magnitude is determined by measuring the amount of ground motion caused by an earthquake. Seismologists express magnitude by using a magnitude scale, such as a Richter scale or a moment magnitude scale. The Richter scale measures the ground motion from the earthquake to find the Earth's strength. While the Richter scale was widely used for most of the 20th century, scientists now prefer the moment magnitude scale. Moment magnitude is a measurement of the earthquake's strength based on the size of the area of the fault that moves, the average distance that the fault blocks move, and the rigidity of the rocks in the fault zone. Although the moment magnitude and the Richter scale provide similar values for small earthquakes, the moment magnitude scale is more accurate for large earthquakes. The moment magnitude of an earthquake is expressed by a number. The larger the number, the stronger the earthquake. The largest earthquake that has been recorded registered a moment magnitude of 9.5. The earthquake in Kobe, Japan in 1995 that caused the damage shown in Figure 2 had a moment magnitude of 6.9. Earthquakes that have moment magnitude of less than 2.5 usually are not felt by people. Modified Mercalli intensity scale. Here is a list of different intensities and the description that goes with them. Intensity. Before the development of magnitude scales, the size of an earthquake was determined based on the earthquake's effects. A measure of the earthquake, the measure of the effects of an earthquake on a particular area is the earthquake's intensity. The modified Mercalli scale shown in Table 1 expresses intensity in Roman numerals from 1 to 12 and provides a description of the effects of each earthquake intensity. The highest intensity earthquake is designated by Roman numeral X11 or 12 and is described as the total destruction. The intensity of an earthquake depends on the earthquake's magnitude, the distance between the epicenter and the affected area, and the local geology and the earthquake's duration.